Hello and welcome to another LeetCode video. Today we're going to be working on Ternary expression parser. And Python doesn't really have ternary, but other languages do have it, and Python has some similar stuff. Like you can return if something, else something. That's pretty much a ternary expression like this. You could say like, number equals 5 if something, else 6, which is essentially equivalent to number equals. And then you just have like a ternary expression here where it's like true or false here. So you'd say like 5 equals 6, question mark. And then if it's true, or actually no, it would be like something here, right? So is this something true? And then if yes, let's return 5, otherwise let's return 6. So these are equivalent, and this is what they mean by these ternary expressions essentially. It's going to be the same thing. Okay, so let's go through these examples. So we have one expression here where we have true, question mark, 2, 3. And essentially what this is saying is, if this is true, we're going to return this side of the question mark, and if it's false, we're going to return this side of the question mark. So that's how it works. So in this case, it is true, so we're going to return this side, so our answer is 2. Okay. Now let's go to the next one. So we have f, question mark, 1, colon, t, question mark, 4, 5. Okay. So in this case, they're saying you have to evaluate these from right to left. So essentially, we're going to be doing this expression first. And this is true, so this is going to actually return us a 4, right? Because if it's true, we're going to take the value to the left of this colon. And if it's false, we're going to take the value to the right. So we're going to take the 4, and now we're left with false, question mark, 1, 4. And now this is false, so we're going to take the value to the right of the question mark. So our answer should be 4 here, and that is the same thing. And so you can see that in these parentheses that this true is evaluated first, and then the false. All right, so this last one is the tricky one, so let's go through that one. And we need to build an intuition of how these work. This one's going to be a little weird, and it definitely took me some time to understand. So the way this works is, because these are guaranteed to be one-digit numbers, we need to look for the rightmost ternary expression. So essentially what we're going to be doing here is we're actually going to be looking for the rightmost question mark expression. So the rightmost question mark expression is actually this one here. This is like the complete expression. And you can't just read left to right because like here there's nothing. So you have to find the rightmost question mark, and then you have to do that expression. And so this expression is saying, if it's true, do this. If it's false, do this. And this is true. So this is going to return to us the value false. And now what we have left is we have false, 3, true, question mark. And now this is true, so we're going to return the value false. Okay. And so I have one more to show you, and we're going to go through this one, and this is going to be kind of a complicated one, and we're going to try to follow the logic of going right to left and seeing if this is correct. So we actually have this one here. I'm going to copy paste it into here. Okay, so this is our expression. Let's actually make it a little bigger if we can. There we go. Okay, so this is our expression here. And we're going to try to do this one. So let's try to find the rightmost ternary expression. So here, once again, we're looking for the question mark. So the rightmost complete ternary expression is this right here. And so this is going to evaluate to false, so we're going to take the rightmost value. So we're going to take a 4 here. Now we're going to copy the rest of it. Hopefully I can just copy the rest of this and I'll have to write it. Let's see here. Maybe I can't. Okay, I guess I do have to write it. That's okay. So we're going to write F1, F, 2, T, question mark. Okay, this is where we're at now. Okay, now we're going to take the rightmost expression again. So where's that? What expression is that? Well, it's actually going to be this one over here, right? And so what is this going to evaluate to? So this is actually going to evaluate to true, so it's going to evaluate to 4. So now we have true, true, false, 1, false. There we go. Now we're going to take the rightmost expression again, which is this. So what is this going to evaluate to? Sorry about that. Okay, go. This is going to evaluate to 4 because it's false, so we're going to take the rightmost value. And so finally, we're left with false, question mark, 1, 4. And now finally, this is going to evaluate to 4 because it's false. And so the nice thing also is if you want to test these expressions, what you can do is you can just go to another language of your choice. You can take this expression and you can actually do this. So you can console log or whatever. If you want to do JavaScript, you can do JavaScript. But because Python doesn't have these, you could literally just type these in yourself. So you could say like, okay, let's just say false. And this should theoretically work where you can just write them yourself. You know, you want to have spaces, but other than that, it should work. But let's give it a try. It was working for me earlier. For this big one, it might be a little tricky, but let's see what happens. So we don't have any parentheses, but let's just see what happens here. So we can actually see in the standard out, we did print out 4. So you can test, if you want to try big expressions, you can just console log them in whatever language. I think this is in most languages, so you can console log or cout or whatever language you're using. But yeah, so essentially, let's just remind ourselves, what are we doing, right? So at every step, like what's our process? So we keep looking for the rightmost question mark and then take that expression, evaluate it, and put the result back in, right? So like we look for the rightmost question mark, we take the whole expression, we evaluate it, we put the result back in, and now we do this until we just have one number / true false left, right? Like at the very end, we should get a completely evaluated expression that's just going to look like this. But the problem with this is like, how would we even do this? Like, would we just take a string? Like, let's say we take a string and we look for the expression. Sure. So we can look for the question mark and we know the expression is going to be a 5-letter expression. And we could say like, all right, let's just take that 5-letter expression. Let's just evaluate it. And let's like reconcatenate the string. But that's not going to be super efficient because we're going to be doing repeated work, or not really repeated work, but essentially we're going to be like, if we have something in an array, we're going to like take stuff out of the middle of an array, right? This is not guaranteed to be in the end. Let's say we just have an array of characters. We can take stuff out of the middle, and we're going to be doing pushes and pops to the middle of an array, which are, as you know, big O of n time. So that's not super efficient. So we need to find a way to make this more efficient. And how would we do that? Well, if you think about it, if you actually look at this picture, every time we do a ternary expression, we just take the 2 numbers that are right behind it. So if we could somehow just store all these numbers or whatever, if we just store everything that's not a ternary expression part, like, so if we just store like this 5, 4, 3, we're not going to store this false because this is part of the actual question mark. We're not going to store this true because this is part of the question mark. So can we just store these like 5, 4, 3 and whatever, and then as soon as we encounter an expression, we just say, all right, let's just take the last 2 numbers we stored, call the expression on those, take a result, and store that. So let's actually show you what that's going to look like. So we're essentially going to have a stack, and we're just going to start storing numbers, and anytime we reach an expression, we're just going to take the last 2 numbers, and then we're going to say like, okay, if it's false, do this, if it's true, do this. So let's see what that's going to look like. So let's have a stack here. And let's actually, so let's have a stack here, and maybe we can even copy this over here. So let's just copy this here, and then let's actually just go down here, try to paste it again. Okay, so this is our, thing. Let's actually paste it, but then let's also make it a little bit bigger so it's easier to see. Okay, now what we're going to do is we're going to have a stack, and we're just going to try to start saving stuff. So let's just show you what that's going to look like. And ideally, we want to just pop the last 2 numbers to do this expression because we don't want to be popping from the middle, right? We want to be popping from the end. So let's just show you what that's going to look like here. So let's just say we start with this last number, right? We're going to go, because we're evaluating these expressions backwards. So just say like, okay, we'll just say if we have a number, then let's just put that number in. So we have a number, let's put that in. We have a 5. Okay, let's put in a 5. Now we have a 4. Let's just put in the 4. Now we have a 3. Let's put in the 3. Now we've reached a ternary expression, right? Whoops. We've reached a ternary expression. We've reached the question mark. So can't I? undo. There we go. So we've reached this question mark. So now we know that we're going to have an evaluation. So this false, we're not going to be storing it. We need to actually get it. So as soon as we reach a question mark, we can just say, okay, let's just take the value that's to the left of the question mark, and there's always going to be a true or false to the left of the question mark, right? Because that's how a ternary expression works. So let's just say if we reach a question mark, let's just take that value, and let's pop the last two items. And now let's figure out, for these two popped items, which one is the true result and which one is the false result. So if you look at it, so the first one popped, is that the true or the false result? Well, it's actually, this is going to be the true result, right? The true result's on the left, the false result is on the right of a ternary expression. So this last number is going to be the true result, right? This is the true result, and this is the false result. So we're going to pop those, and then we're just going to say, okay, let's just look at what we have, and then whatever it is, if it's false, we're going to push in the pop results. So we're going to pop these out. So these are going to go out. And then we're just going to simply push back in this false result because we have a false expression. Okay, well, let's just do that, right? So we're going to push back in a 4. And now this is no longer in our stack, right? We pop those out, we push back in a 4. Okay, and then we essentially, since we got this false, like, because we hit a ternary expression, we just said, like, okay, what's the number before the ternary expression? Now we're actually here, right? We're going to skip this false because we already got it. So now we're at another ternary expression, and we're going to say, okay, we're at a ternary expression, that's fine. Let's get the thing before the ternary expression to tell us what to use. So we're going to do that. So we're going to say, okay, let's just look, what do we have? We have a true here, right? Sorry. Okay, so we have a true here. And for this true, let's pop again, right? And so what are the values? So we've kind of established that if you look at it, the first value popped is the false value, and the second value is the true value. Let's see if that's true again. So this part here evaluated to 4. So what's the true value and what's the false value? So this is the true value, right? This is the true value. This is the false value. Same thing again, right? First one popped is going to be the true, second one popped is going to be the false. So our stack, if you want me to redraw it, is actually going to be this. This is going to be our true value, false value. We're going to pop both of them. And then we're going to say, okay, well, do we have a true or a false? We have a true. So let's just push back in the 4, right? Because we have a true. So now our stack, well, I'm going to draw it over here, is going to look like a 4. Okay. So this is out of the stack. Now we just have a 4 back in there because it was pushed back in. Okay, so now let's keep going. So we went through this. Now, by the way, so I skipped these colons. So when we hit a colon, we can just ignore it, right? Like when we hit a colon, it's not a number, it's not a question mark. So anytime we hit these colons, we can just say, like, let's just keep going. So now we hit a 2, that's not a question mark. So we're gonna put the 2 into our stack. So let's do that. Let's put the 2 into our stack. Oops. Okay. Now we hit a question mark again, and we're gonna say, okay, we're gonna need to get, is this true or is this false? So we're gonna go one more over here, and we're gonna say, okay, well, this is false. Once again, remember the first value popped is true, the second value popped is false. So we're gonna pop both of these, and then we're saying, oh, we need the false, so we're gonna put in the 4, right? So now this whole thing is done. Now we are going to go over here, right? So we have a colon again, we don't care, 1. Okay, we do care about the 1, so let's put in the 1. Now we have the false, or sorry, we have the question mark. And so because we have a question mark, we're going to say, all right, let's pop both of these again. So we're going to pop both of these. This is the true value, this is the false value. And let's actually get what's over here. It's false. So we're going to push back in the 4. And so now our final result looks like this. And we went through our thing, and then our final result is here. So as you can see, if we just store the numbers in a stack, then we can always pop from the back, and we can just say anytime we hit a question mark, let's actually write this down for like all of our logic. So make a stack, push numbers, or this could also have true falses, or true false in if, or just, yeah. And then once we hit a question mark, let's get the value there, true or false, right? So true or false, and let's pop the last two elements from the stack, and then if value equals true, then let's push the true number or whatever value in, right? So true value in. Else, let's push the false value in. Do this until we finish the expression. That's essentially what we're doing is we are, every time we hit a question mark, we're going to say, what's the left of the question mark? Is it true or false? And then we're going to pop our two values. And then remember the first value popped is the true value and the second value popped is the false value because it's backwards. Okay, so now that we have this, we have enough to be coding. So let's do that. I'm actually going to move this over here so I can reference it if I need to. Okay. So now let's go back into Python and let's actually start coding this up. So first thing, we're going to make a stack. So stack. Second thing, we're going to be iterating through our expression backwards. So I'll just say like index equals length or length. I definitely have been coding too much in JavaScript, so I've been making a lot of mistakes there, just writing JavaScript syntax in Python lately. That's okay. So we can just say while index is greater than or equal to 0, this is essentially going to go through our expression backwards. And then until the index is -1, you know, that's when we know we went through our expression. Okay, so now we have our if statement. So let's just say if the, what are we looking for, right? We're looking for a question mark. So if expression I equals a question mark, then what do we need to do? Well, we need to figure out if we need to have a true or false value, but we also need to pop the last two numbers from the stack. And this is going to be a guaranteed, like, valid expression, so there will always be at least two values in the stack once you call this question mark. So we need to pop those out, right? So we're going to say, like, true value equals stack.pop, and then false value equals stack.pop. And then finally, what we need to do is we need to, this is not lined up correctly for some reason, weird. And I think this is not lined up correctly either. Okay. So now what do we need to do afterwards? We need to actually figure out like what's to the left of the question mark, right? So we're gonna say, let's just decrease the index one more time so we can get that value. And then we could say if expression at I is true, then let's actually, or we can do it like this, true, then let's actually pop in or push in the true value, right? So we're going to say stack dot append, or not append, append, right? Append true value. Yeah, I've been mixing up appends and like pushes and stuff. Okay, so if it's true, we're going to push in the true value, right? Because we want to push in the true value. Otherwise, we're going to append the false value. And then finally, we need one more thing. So we need an else if here. And we check for the question mark, but we also care about anything. We care about anything that's not a colon. So we can just say else if expression I does not equal the colon, then we're going to push that into the stack. So stack.append expression I. And then, so basically what's going to happen here is if we hit the question mark, we will do our question mark logic. And if we hit a colon, or sorry, if we don't hit a colon, then we have a number or a true or false that we actually need to push into the stack. So that's what we're doing here. And then finally, if we hit a colon, we don't care, so we can just move on. And now, theoretically, there should be only one number in the stack after we're done. So let's just see what happens. Okay, we got some errors as always. So this should be I. I'm just going to make this I just to make it easier. I think I have more I's than indices, so let's see how many more errors we have. Oh, I forgot one more thing, actually. Right. So regardless of which one of these we have, we actually need to decrease our index, right? Like we did decrease it. So when we hit a question mark, we have to decrease it twice, because when we hit a question mark, we want to decrease it once to get this true or false, and then we need to decrease it again to go to the next character. But if we don't hit a question mark, we still want to decrease it. So we want to decrease it no matter what we get here. Okay, we have index, so let's just do I. Okay, hopefully that worked. Okay, nice. And it's pretty efficient. So let's go through the time complexity of the solution. And yeah, I do think like the tricky part about this problem is just recognizing how ternary expressions work. They're a little weird, especially for this example. Once you get through like this example and some bigger stuff, like this thing I showed you here, you know, if once you get this, you understand like how this works, then you're pretty good. Okay. So the time here is we are looping through the expression, and then worst case scenario, at every single point, we will have 2 pops and a push, which is, you know, time 3. So that's still going to be big O of n for the time. So that's pretty straightforward. Now for the space, what do we have? So this is also going to be big O of n, right? Because we're going to have a stack, so we are going to be pushing onto it. So this is going to be big O of n. I don't think it's actually going to get to like big O of n, but I think it can be somewhere around like n over 3 or n over 4 or whatever it is, which is still going to be big O of n. Right? Because for every single one of these, for every single expression, you have something like this. So, you know, 2/5 of the expression are things you are going to be storing on the stack or somewhere around there. Not exactly, yeah. It's not going to be exactly. Like for this one, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're storing 2 out of 9 things in here. But either way, right, if it's like 2/9 or 2/5 or whatever, that's still big O of n. Okay, so that's actually going to be it for this problem. Hopefully you liked it. Definitely think it's a good problem. And if you did like it, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.